Hello. So last time from the previous video we talked about this concept, the concept of the cylindrical shells method, and then we discussed case 1, just this concept of case 1. So now we're going to do an example. So here the region is given as y equals x squared, y equals 0, x equals 1, and x equals 2. And the rotation is about the line x equals 1. So the first step of the solution is to graph or to sketch the region. So first we graph y equals x squared, and y equals 0 is the x-axis, x equals 1 is this vertical line, and then x equals 2 is the other vertical line. So all those data give us this region in yellow. And then the line of rotation is x equals 1. It's a vertical line. So we mark the rotation. So now we're going to revolve this region about this line x equals 1. But we want to use what we call the shell method. So this also can be solved using the disk method, but this time we're doing the shell method. So we go between 1, x equals 1 and x equals 2, we pick an x. Okay, x is any point between 1 and 2. So we pick an x, and then from x we trace x vertically to the curve, and that's when we're going to draw our cross-sectional rectangle. And then this cross-sectional rectangle must be parallel to the line of rotation. Anytime you're doing the cylindrical shell method, the cross-sectional rectangle is always parallel to the line of rotation. So we're going to take this cross-sectional rectangle, we're going to revolve it about this line of rotation, then it's going to create a cylinder. We call that cylindrical shell. It's going to create a cylindrical shell. So then our question here is, what is the height of the cylindrical shell created by rotating this rectangle about the line, the vertical line x equals 1. So the height of the cross-sectional rectangle is basically the height of the function, because at this point here we have y equals x squared. At this point we have y equals 0. So the difference between y equals x squared and y equals 0 is x squared minus 0, which is x squared. So we write down the height as a function of x, which is x squared. H of x equals x squared. The radius of the cylindrical shell is the distance always between x to the line of rotation. X to the line of rotation. So the distance between x and 1 is x minus 1. So that gives us the shell's radius. So we have two things that we need: shell's radius and shell's height. So then we just go and go to the volume. How do you find the volume of rotation? Using the shell's method. You're going to integrate from a to b. You will integrate 2 pi times the shell radius and then times the shell's height, and then you put dx if your point you selected is x. Okay. So this time we got shell's radius is x minus 1, shell's height is x squared. So you have a v is the integral from 1 to 2, 1 to 2 because the region is bounded on interval 1 to 2. So now we have this calculus 1 integral. Before we do it, we'll have to distribute x squared. So x squared times x is x cubed, and then x squared times negative 1 is negative x squared. and then 2 pi is a number, so we just bring 2 pi down, and then find the antiderivative of x cubed, which is x to the 4th over 4, minus antiderivative of x squared is x cubed over 3. So we plug in, then after that we're going to evaluate this expression into 1 and 2. So we plug in a 2 first, always the upper limit first. Plug in 2 for x into the expression, minus, and then plug in 1 into the for x into the expression for x. And then we just work it out. We so what I did here, I found the common denominator. Okay, and so you get like 3 times 2 to the 4th, and then 4 times 2 to the 3rd, and all divided by 4 times 3, which is 12. Similarly, I found the common denominator here, which is a 12, and the numerator get the 3 minus 4. So we have 1 over 12 and then 1 over 12, so I factor out 1 over 12, and then I have the numerator, which is a 3 times 2 to the 4th minus 4 times 2 to the 3rd, and then this 3 minus 4 is negative 1. Because of this minus sign, it becomes positive 1. And so here if you take, so this 2, the difference, this 2 give us 16, then plus 1, so you get 17, and then multiply 17 by pi, you get 17 pi over 6, and then you're done. I kind of explain how you get 15 here. Okay, thank you very much.